Good morning or good afternoon, everyone, in whichever time zone we are. I will be giving you a brief introduction to computer software and its application. Now, Mr. Williams would have done a session on hardware earlier. Software is pretty much the opposite of hardware in that you cannot touch it. And computer software, or software as it's simply known, they're computer programs. It's non-tangible, which means you can't touch them. It contrasts with hardware, which is the typical component of the computer. Now, hardware and software, they require each other, and neither can be realistically used without the other. In other words, hardware would not function without the software, and software cannot run without the hardware. Now, it includes all computer programs regardless of their architecture. For example, executable files, libraries, and scripts are computer software. Now, software consists of clearly defined instructions that, upon execution, instructs hardware to perform the task for which it is designed. Now, software is stored in memory and cannot be touched, just like a 3D model shown in an illustration cannot be touched. In other words, it's all virtual, you cannot touch anything. Now we move on to application software. Now, application software is the computer software that causes the computer to perform useful tasks beyond the running of the computer itself. A specific instance of such software is called a software application. Application program, application, or app. Now, most software these days, we term them as apps. We don't really use the word software on a general basis. Now, the term is used to contrast such software with system software, which manages and integrates a computer's capabilities, but does not directly perform tasks that benefit the user. So, in other words, the applications run on system software, which will be the operating system, which will be covered in a little bit. Now, some examples of application software could include accounting, enterprise, graphics software, media players, and office suites. Office suites being like Microsoft Office suite that we use, which includes Word, Excel, Access, and so on. And media players like VLC, Windows Media Player, and so on. Now, many application programs deal principally with documents. Applications may be bundled with the computer. For example, Windows Media Player, for instance, and Internet Explorer are two applications that come built in with Microsoft Windows. Or they may be published separately. For example, Microsoft Office, which you can either download a copy and pay for it, or you can buy it directly from the store and install it on your computer. Application software applies the power of a particular computing platform or system software to a particular purpose. Now, some applications are available in versions for different platforms. Others have narrow requirements and are thus called, for example, like a geography application for Windows, an Android application for education, or Linux gaming. They're all specific to each OS or purpose. Sometimes a new and popular application can arise and runs on one platform, increasing the desirability of that platform. This is called a killer application. In other words, if this particular application or software only runs on, let's say, Linux or Windows, and it's not supported on like Apple or Mac, then the desire to get a Windows machine to use that specific software increases. Now we turn to operating systems. Now, an operating system, or OS, is a collection of software that manages computer hardware resources and provides common services for computer programs. This is the main software that the computer runs on. It's an essential function, or component, of the system software in a computer system. Now, application programs, like we just discussed, would need an operating system or the main software program to run on. Now, for hardware functions such as input and output and memory allocation, the operating system acts as an intermediary between programs and the computer hardware. although the application code is usually executed directly by the hardware and will frequently make a system call to an OS function to be interrupted by it. Now, operating systems, or OS, can be found on almost any device that contains a computer or runs a computer, from cell phones to video game consoles to supercomputers and web servers, and even gaming systems or game consoles. Yeah. Examples of popular modern operating systems would include Android, which is powered by Google, that's run on like Samsung Galaxy phones and Motorola phones and so on. BSD, iOS, which is Apple, Linux, which is open source, OS X, which is also Apple, which runs on computers and laptops, Microsoft Windows, which I think is probably universally famous worldwide, Windows Phone, and IBM. All these, except Windows, Windows Phone, and ZOS, share roots in Linux. Now we come to proprietary software. Now, as the word proprietary may suggest, it's closed source, which means it's kind of restrictive. It deals with licensing. In other words, it's computer software licensed on the exclusive legal right of the copyright holder, with the intent that the license is given the right to use the software only under certain conditions, and restricted from other users. And you cannot modify it, share, study, or be allowed to redistribute it or reverse engineer it. The source code for these software is not made available. They are restricted. Now, complementary terms include free software licensed by the owner under more permissive terms, and public domain software which is not subject to copyright and can be used for any purpose. Now, examples of proprietary software can be, like, for example, our Microsoft Windows operating system. We cannot modify that in any way. The code for that is locked, more or less. Whereas with a machine that runs Linux, we can sit down with that and manipulate it and play with it to suit our needs. And now we come to open source software, which I mentioned a bit earlier. This is pretty much the opposite of proprietary software. It's computer software with the source code made available and licensed, with a license in which a copyright holder provides the rights to study, change, and distribute the software to anyone and for any purpose. Now, it's very often developed in a public collaborative manner. In other words, a lot of people work together to make this project a reality. Open source software is the most prominent example of open source development, and often compared to technically defined user-generated content or legally defined open content movements. Now, a report by the Standish Group from 2008 states that adoption of open source software models has resulted in savings of about $60 billion per year to consumers, primarily because it is free and very much more easier to use in some cases than the Windows platform. Now, Windows is still popular, but it's now being, Linux and open source development is now coming around to be used in various applications worldwide. And at UG, we've started to host open day functions, which focus primarily on open source software, which we're trying to, get out to our populace for them to use and see its benefits and so on. So this has been a very brief session on software. Of course, software is much more high-tech than this. It's very much a foundation of software engineering. But if you have any other questions on it, you can feel free to email me. My email address will be at the bottom of the screen. And I will be available to answer any questions, or if you need any information, I will be able to provide it. Thank you.